In this lesson here, we're going to be taking a look at how do we create a quadratic equation. Now remember that a quadratic is going to look something like this: y equals x squared minus 4x plus 4, let's say. Okay, that would be a quadratic equation, or you could have something like y is equal to negative 3x minus squared minus 2x plus 4. There we go. Okay, so we'll just try out a couple different ones there. Those are quadratic equations. Now, to come up or to use these is fairly straightforward, because all we need to do is plug them into Desmos and then use them, right? So we can kind of find what values we're using and so on and so forth. But the important thing is that we have some sort of equation to use. Now it could look like this, it could look like in vertex form, it could look like it's in factored form. Any one of those three is going to work to put into Desmos, but we need to get to that point first. So if we want to analyze anything with Desmos, so graphs, equations, and so on and so forth, we have to have that equation to start with. Okay, so we have to be able to come up with that equation array to start. Now there's a number of ways that we can make this equation. We're going to look at 3 of them. 2 of them are going to involve using algebra in some form, and then the third one is going to involve using Desmos. It's important that we understand how we use algebra first, and then we can go through how Desmos does it a little bit simpler. Okay, a lot simpler, but we still need to know the process, because it's something that you will be using for this unit as well as next year when you move into grade 12 applied math. So the first one we're going to take a look at is vertex form. Now remember that vertex form is y is equal to a x minus h squared plus k, where a is going to represent how wide and narrow our graph is, if it opens up or down, and h and k represent our vertex. Okay. So with this one here, we need to know at least 2 points. We have to know the vertex, and the other one can be any other point that's along a parabola. And so just as a quick little aside here, here's our sorry, I'm going to draw that a little bit differently here. Scratch that one out. Okay, so here's our x, y, and in the case that we're dealing with here, we're going to have a vertex of 2, 4, which is about right there. Okay, I could use that other one. Mistake there. Okay, so 2, 4 is one point here. This is going to be our vertex. So we know that our parabola is either going to come like this, or it's going to go like that. Okay, we don't know which way, but we know this is going to be our vertex. That's going to be our max or min. The second point that we know that is on our graph is 6, 2, which would be somewhere here, right about there. Well, look. Okay, so it's got to be this one right here. This is going to be our parabola, or our quadratic. Okay, so that's going to be our quadratic because we have our vertex and we have some other point right here that we know. Okay, and you'll always be given a second point that's along the graph, and it's important that we understand that that point does satisfy the whole problem there. So we have a parabola that has a vertex and it has another point. We want to determine an equation or a parabola which goes through, or for the parabola, it should be 4. I'll have to change that in the master copy. For a parabola which goes through those points. Now if we're given the vertex and one other point, we're going to use our vertex form, which x minus h squared plus k. We're going to use that to create our graph, or create our equation. So a couple things that we know. We know the vertex, so we're going to plug our vertex into this. Y is equal to a x minus 2 squared plus 4. Sorry, all the mistakes here. Okay, so we're going to plug that into our form. Now again, the form that we have here represents our equation, and so we're going to try to plug things in so that we can come up with the equation. Now you'll notice here that we have h and k, but we don't know what a is, and in no way in this example here are we given the value of a. By just drawing it out, we know that it's got to be negative, okay, but we don't know what the value of a is going to be. So we have to solve for what is a, and this is where the algebra is going to come in. Now the only way to figure out what value of a is going to work here is if we know some other point, x and y, that is on our graph. And that's where we're going to use this 6, 2. So we're going to use this point to figure out what value of a makes this whole thing work. Okay, which value of a is going to make this whole thing work. So we're going to plug it in there. So 2 is the y value, 6 is the x value, and now we can figure out what value of a is going to make this point work with this vertex. Okay, that's what we're trying to do. We're trying to figure out what value of a makes this whole thing work. So now all we need to do is just solve for a. Okay, we can do that by kind of calculating whatever we can. 6 minus 2 squared, that's 4 squared is 16. So this would be 2 is equal to a times 16 plus 6. We want to get a all by itself because we're trying to solve for what a is. So we need to subtract 6 from both sides. Is equal to a times 16. And that gets rid of that. Then we need to get rid of that 16 because, well, we need to get a all by itself, so we divide by 16. And our a value is equal to negative 4 over 16, which, if we simplify it, is negative 1/4. Okay, now, usually if I'm giving you a question like this, it's going to have some sort of, I'm going to call it a nice fraction. It's not going to be some sort of wacky fraction. Could be. Or it'll be a whole number, either or. But this is our value of a. That's the value of a that we need to plug back in there. So we use that to come up with our equation. Y is equal to negative 1/4 x minus 2 squared plus 6. And if you were to plug that into Desmos right there, you would get this this parabola. And then you'd be able to figure out any other point. So if y equals 6, what is x? If x is equal to 12, what is y? So on and so forth. And then you could solve that. You could also convert this into general form, okay? So something like this, just by multiplying it out. So x minus 2 squared, you would find that. You'd multiply it all by negative 1/4, and then you'd add 6 to the end, and you would get what your equation is. If you want to leave it as this, that is just fine, because that is already an equation which matches the parabola. And so you can use this in solving for anything else. Now again, I say here, number 5, convert the equation to general form. Only if you absolutely need to will you do that. And to do that, x minus 2 squared is x minus 4x, x squared minus 4x plus 4. And we multiply everything by a quarter, so y is equal to negative 1/4 x squared plus x minus 1 plus 6, and so y is equal to negative 1/4 x squared plus x plus 5. That would be in general form. Okay, so multiply out this x minus 2 squared, we multiply that out, and then we multiply that by negative 1/4, because that's multiplied to the brackets. Then we add 6 to the end, and that would be our general form. Now again, if we put this or this into Desmos, it's going to give us the exact same parabola, so we don't need to convert it to use Desmos for it, but it's sometimes nice to at least be able to see what it looks like in general form as well. Okay, A, B, and C in our general form equation.